an introduction first. So again, welcome everyone. I think we have a nice group, but it's small enough to actually be a little bit more interactive. So if you do have questions or you want us to slow down or something, then feel free to put your hand up and we'll make time for that. So let's start with our Builder Showcase introduction. So first about me. Almost everyone here knows me, and knows me by my real name. One of the things we're doing at Powerhouse is we are enabling pseudonymous contributors to be part of DAOs and to contribute to the fullest extent. So if you will find my profile on Connect or Renown, then you will find me as Prometheus founder. My background is in computer science. As most of you know, I worked as a MakerDAO contributor from 2017 till about 2023. And then since 2023, my focus has been on Powerhouse mostly as the founding member there. So you want to follow me on Twitter, you can find it there, Prometheus_PH. So yeah, as I mentioned, I've been around for quite a while in crypto since 2017. I've been part of the Maker Foundation back when it was creating the multi-collateral DAI protocol. And yeah, this is from the beginning, especially when I talk from my own perspective, has been an interest in imagining decentralized organizations. So building the multi-collateral DAI protocol with the teams at Maker was very exciting as a DeFi primitive, but I always wondered like how this would ladder up into truly decentralized organizations. So in 2021, the Maker Foundation then dissolved and Maker became truly MakerDAO. So that was a very exciting time because back then and so for a very long time, that was essentially the biggest experiment in decentralized operations or organizations that has happened. And I transitioned from my own role in the Maker Foundation to a new role because, in the DAO, the roles and responsibilities are quite different from a centralized organization. And so I was wondering how I can contribute to MakerDAO, and I co-founded at that point the MakerDAO Sustainable Ecosystem Scaling core unit, which is one of the teams in the MakerDAO back then. And so again, at that point we worked with people to further explore decentralized organizations. What the Maker Foundation was doing in dissolving and then creating the DAO was a really unique experiment, and there were a lot of questions to be answered. So for example, we had an incubation program at the time helping some of the teams to get onboarded on the DAO, help them to figure out how is working for a DAO different than working for a centralized organization and so on. The MakerDAO experiment ran for about 2 years, and then the bear market kicked in, and the size of the DAO was such that the inefficiencies of the decentralized organization at that point became quite clear. And that's essentially when the plug was pulled and there was a new plan that was kickstarted, which is the Maker Endgame, championed by Rune, the founder. So that was the end, I would say, of the most radical decentralized organization experiment at that time, because a lot of the organizational structures became more centralized again. But MakerDAO has never given up the ambition to one day decentralize again. And so that's actually where we come in. So I continued a little bit with the MakerDAO Sustainable Ecosystem Scaling core unit, but then quickly joined the Powerhouse project as a separate project, and we are focusing on decentralized operations, not just for Maker, but in general as the big question of how can we create functional, effective, scalable, decentralized organizations. And so since then, DAOs really haven't changed a lot. I took this screenshot here of Twitter thread that was happening just yesterday. And this is Vitalik saying that in the reaction to a quite critical talk about DAOs that was made by Leftaris, essentially saying that DAOs aren't real. It's window dressing. Decentralized organizations are very difficult, and what we call DAOs today, they're not truly DAOs. And one of the statements was that, well, what are DAOs? DAOs are not companies. And then Vitalik made, I think, a very useful distinction. He said long-lasting, so the DAO is a long-lasting thing that provides a service that needs stability. That is a very different DAO from the DAO that people typically think about as essentially a team with a Discord and a multisig. And so recognizing also that an organizational structure needs to adapt to the scale. And then as for the current state of DAOs, well, it's pointed out that DAOs as a long-term vehicle, they have not been done right. And those that tried to do it may have ended up creating expectations in terms of decentralization and the structure of the organization that might not be in line with the reality always. So really, today still, DAOs don't scale. So at Powerhouse, we very much do want to return to that initial question. And so with all our experience from MakerDAO, why is it that DAOs don't scale? And so we like to think of it as a scalable DAO. The original promise should be able to build a decentralized Uber, a decentralized Airbnb, and Netflix, and so on. And so why do these open and decentralized platforms not exist? And I think for everyone who has been collaborating or contributing to DAOs today, it's pretty clear that there is just a lot of coordination failure in these organizations today. And generally speaking, there are many, many factors, and it's a complicated picture, but generally speaking, it's coordination failure in DAOs that leads to uncompetitive outcomes. So you can't even imagine today a DAO actually competing with, for example, an Airbnb. That it's almost laughable. And so there is a failure to deliver complex integrated solutions with a good user experience. The only option you have today is to create a Web2 SaaS company if you really want to do that. If you want to stick with a real DAO, you will need to keep it much smaller. There's a failure to reach consensus on direction and strategy. I think that one too is very relatable. So if you were part of a DAO, you probably find it very chaotic, not knowing what the long-term plan is, or if you did know, maybe it wasn't all that decentralized at all. And even if DAOs would have good mechanisms to reach consensus, they would fail to actually plan and execute. There is also, ironically, a lack of transparency. For example, at MakerDAO, everything happened on the forum, and you would think that is as transparent as it gets. But the issue is that there is such an information overload that people don't find even the answers to the most basic questions, such as who are the core units in the DAO, what are they working on, how much are they getting paid, and so on. There's also a lack of accountability that is a result of that, because if you don't know what's going on and who's working on what, then it's difficult to keep people, make people responsible and hold them accountable. And then the same issue in a different way is that ultimately, if there isn't enough focus on the real priorities and the priorities aren't known, then you will get people doing all kinds of random stuff, and that then leads to a lack of sustainability. A DAO needs to have a clear targeted plan to become sustainable. So at Powerhouse, we've been thinking about how to remedy this and how we can, in the medium to long term, build truly scalable DAOs. And so the model we've created essentially says that we need more than just a smart contract or a multisig or a governance token. So what we propose is to evolve DAOs towards something that we call a scalable network organization. And so there are scalable network organizations, the way that we define them, they're quite similar to DAOs, and DAOs are, you could say, they're a subset of it, but maybe not very scalable today. But a scalable network organization essentially is an organization that is open and transparent. So it is freely accessible. It has the gradual onboarding path. It has that feeling of I can just join the Discord channel and I'm part of the team. It works on open source and open data as a default. And the really important thing is that it is competitive because it leans into the networking effect. So this is the one competitive superpower that DAOs have, is the openness. And if you are building a DAO but you keep it closed, then you're better off just creating a centralized organization because you're not going to win if you don't make use of those networking effects of an open organization. Maybe on the one hand, may almost sound trivial, but key part of the definition is that a scalable network organization should use a software platform to coordinate and also use a software platform to offer its services. This makes sense if you think about it, because in a centralized organization, you have a middle management pyramid that can take care of the alignment within the organization, help the teams to figure out what they're supposed to do, how they're supposed to do it, and so on. But what we're looking for is something more like an Uber or an Airbnb, where joining is as easy as just opening up the app and logging in. So we want a scalable network organization that has a scalable marketplace platform the way that Uber and Airbnb are scalable. The reason why that works is because these organizations have their best practices embedded in software, and they then can do progressive automation, which is the way that they get efficient enough to basically recoup the cost of developing the software platform in the first place. And then, of course, we want our scalable network organizations to be decentralized. Decentralization always comes in many flavors, so there should be decentralized ownership to avoid lock-in, because this is one of the greatest points of frustration, I think, with SaaS platforms today, is that the content creators and the members of these platforms, they really are 100% bound to the company that is offering the service, and they can get deplatformed, they can lose their income. If you're building a career on a platform, you're very, very, very dependent on the producer of that platform. We don't just end it with ownership. We also want to have decentralized operations in the true way that MakerDAO tried it in the beginning, and we do want to have, of course, decentralized infrastructure to support all those organizational pieces and make it a truly decentralized organization. So now, what is the role of Powerhouse in all this? So Powerhouse is essentially bootstrapping a network organization of builders and service providers operating under a unified brand. So we are offering, first and foremost, an organizational framework and the technology to evolve network organizations from a service provider network. The thing that Vitalik was bringing up, so the DAO is an organization offering a service, to evolve it from a service provider network into a successful platform economy, the kind that the Ubers and the Airbnbs are. And then secondly, because a scalable network organization needs a decentralized operations platform to coordinate and operate, because that's what makes it scale, we are building that for ourselves and other network organizations covering finance, legal, governance, and people ops. And this is essentially continuation of our work at Maker, but with a broader scope and a more productized approach, so that not only Maker develops this platform and keeps it internal, but that the investment can be used for other organizations as well. So that sounds all very nice, but maybe a little bit abstract. So what does that look like in practice? So first, we're going to have a quick look at the work that was done for MakerDAO operations. So the proof of concept that came out of our time at the MakerDAO SES core unit with two things. So one is a workflow example of the real asset portfolio reporting that we built, which is a proof of concept of one of the key concepts that we'll be talking about, document models. And second, we'll look at the decentralized operations platform to give some idea of what a scalable network organization coordination platform might look like. The most important part for today is, of course, the builder showcase. So we'll talk about rapid application development for DAOs, why it's needed, and the use of document models, which is a new data primitive. And then finally, we'll tie it all together to bring it back to scalable network organizations and how can we use these primitives to build truly scalable network organizations. And with that, I'll hand it over, unless there are any questions or comments at this point. Sounds like it's all clear, so I'll hand it over to T, or Teep rather, who is going to show you the MakerDAO operations proof of concept.
Hear me? Okay, so picking up where Prometheus left off, I thought I'd include this one slide just to get everyone sort of a brief introduction into what the real-world asset reporting flow basically was. So it came about from problems from stakeholders, basically that all the real-world asset reports were reported on in different ways, and the data format wasn't the same across the different reports, which meant that it was very difficult to compare and contrast the performance of the different reports. So what we did is to create a solution, which you follow the flow here, where an arranger logs in with Renown, which means that their Ethereum identity would be tied to any operations that they completed. They'd then go to Connect, where they'd have access to their reports. They would submit the reports, like add transactions. They could also add proofs for the transactions, which would be something like a bank statement or something like that. They would then send the portfolio reports for review, which would go to someone called an operator or maybe like an auditor that would then review the evidence and the transactions, and then they could accept or reject or basically ask for the reports to be updated. And then that data could then be shown on third-party integrations. So what we're going to do is do a quick demo of that flow and show how it works, and then show in production environment basically one of the integrations that's already live. So we start off here in Connect, and for people that aren't familiar with the Powerhouse suite, Connect is sort of the contributor portal where users can input their data and interact with different document models. So on the left side here, we have the different drives that are available. So like Prometheus said, the ownership of data is very important. So you can access your documents in your local drive, and they can be very secure. They can be stored on your device, and you have access to export them. Or then you can use sort of public drives that are accessible by people that have authorization to access those. So what we'll do here is access the core dev public drive, and we can log in with Renown. So we're now authorized confirmed, which means that when I return to Connect, if we give it a second, we will be logged in with my Ethereum identity and my ENS. So every operation that I complete here will be tied directly to that Ethereum address. So if I change a report or submit a report, someone can check if they know who owns the address, who did that. So we'll go now to a report that I created in advance to show how a transaction can be submitted. So I've already added here an asset and a cash balance, which basically means that the portfolio is holding some cash and it owns also an asset. So what we can do is go to the transaction tab, and we can create a transaction, and we can use sort of the fields that have pre-populated data like enums to select the specific transaction type that we have already defined. So we can do an asset sale. We can say the sale happened right now, and we can assign it to an asset. We can say that we sold maybe 1 million, in this case they're T-bills, 1 million for $1 million. And we can also add a transaction reference if that happened on chain, or maybe a bank account reference. We can save the transaction, and that update will be propagated to the portfolio tab. So we now have 1 million less of this specific treasury bill. So this change was immediately also sent to Switchboard, which is the API. And we can see that here. So if we open that, and we can see that the transaction that we completed here, the asset sale, is also already available in the API. So it's available globally. If other people are using the same drive and have access to the same document, they'd have access to the data immediately after I saved it. So the transaction that we just added then was a manual input. But if we go to revision history, we can see the fields and the data that was added tied to my address, such that you can see how in the future we can easily automate these transactions, and you can see how AI could be laid over the top. If you define the data model and you define what type of transactions you need to add, then you could have AI complete that report instead of a human. So this is the interesting, it's the development environment though. But what's more interesting is the production environment where we have a live integration. So here we see the Connect production environment with the Sky drive. And here are all of the RWA reports, old and new, that have been populated with data. So if we navigate to Block Tower Andromeda, which is the largest report, you can see here we have like 50 assets with over 300 transactions, with all of the data that's been populated and calculated based on what's been input. So you can see all of the transactions here and all of the different types. And again, that data is live in Switchboard in a big response and available to be integrated in third parties or with external developers if they want to use the data. So there's a live integration specifically with this RWA data on the Sky info.sky.money, the new Sky website. So if you navigate to the collateral section and you go to cache RWA, you see two of the reports that have already been brought through. They're the two active ones, with Monetalis being offboarded recently. And if you click through to Block Tower Andromeda, what this portfolio details section here is a calculation based off of the underlying data in our API. So what BA Labs did is they grouped the transactions based on asset purchases, and they got a cost total number here. Cash balance, a similar thing, they queried the cash balance of the portfolio. And if you go to view more, you can see how they have a portfolio and events similar to our portfolio transactions section, where they can sort of format the data however they see fit. So that's great, but it's very specific workflow just for RWA reporting. Well, another one of our products, which is much more broad, is the Sky Fusion dashboard. So this was originally the MakerDAO expenses dashboard, and it was created from a need to understand the expenses of MakerDAO, and as Prometheus said, who is working and what they're working on. And slowly over time has grown to cover more Maker Sky specific sections, such as roadmaps and endgames. And if we scroll down the homepage, you can see the breadth of the data here. So at the top you have finances, so specifically protocol like revenue and expenses here. And then on the right side you see realized expenses segmented by the different teams, so legacy and the progress to the new era, which is scopes and ecosystem actors. Then we have a governance section, which is maybe more applicable to many different DAOs, which links directly to the Sky voting portal. We also have a forum section where most of the active discussions for Maker Sky goes on. And the contributors section was one of the original ones where stakeholders basically told us that the information costs are very high to try and understand who's contributing, what they're working on. So we set this section up as a basically easy way to find out who's working at the Sky ecosystem. And at the bottom here, we have a new section called Roadmap, and it allows contributor teams to report on the work that they're performing. And we also have tied coordinators or contributors to this roadmap section. So you can see in the future, in a world where we have renown and reputation tied to contributors, you can see here if you could tie my name to a successful project, that would maybe boost my reputation more than a project that wasn't delivered on time, for example. So each one of these sections is the sort of highest level, but you can drill all the way in. So if we take finances, for example, you can drill deeper and you can see analytics on the different sort of era levels, so legacy scopes, and immutable, which is the new Atlas stuff. And then you can drill even further in to the different scopes, and then even further in to the different teams. And the base of all this is the Powerhouse. This is the Powerhouse report, is the underlying transactions. So we have a flow here where the funds leave the maker protocol, they leave the control of the protocol, they go to the operational wallet, they come into the operational wallet, which is used to pay payment processors and contributors, and you can see the whole flow here. Again, there's a very specific section for endgame, which shows the transition from the old era of MakerDAO to the new era of Sky and the endgame. So you can see that there's like a lot of data on this platform, but it'd be very expensive and slow to customize the platform because there's a lot of specific things that wouldn't be applicable in other ecosystems. So basically this has spawned the need for a new builder platform. So the builder platform will support rapid application development through model-driven development, and it will support code generation. So basically, what does that mean? It will support a range of roles and agents to conduct their section of the workflow towards components, to towards building useful and reusable components. So the way that this platform was built out, it was like, what do we need next? What do we need next? Add an extra section, add an extra section. In the future, my role as a business analyst, I can work on defined sort of small specific components that can then be tied in to other roles so that we can build these building blocks and then provide a solution that's more customizable. But T will talk more about the builder platform next. Thank you.
You might all be thinking, wow, that's pretty impressive. At least I think it's pretty impressive what's out there. It's a very sturdy proof of concept of what is possible with the vision that Powerhouse has. But the question now is, how do we scale this towards the many customized workflows that we need in our industry, and that the DAOs need to go beyond the Discord chaos that they are existing in right now. So we need a customizable, lightweight, and flexible technical primitive for rapid application development, as Teep just introduced. And that's where I'll take the time today to introduce document models to you. So document models, an open source primitive or an open source data primitive for decentralized operations. Let's look at it with a small introduction, and then Liberuum is going to help me with a development demo for all of you. So what is document modeling exactly? It's an existing software architecture or principle that has quite a bit of rich history. It comes down to a process where you are looking at a business practice or a best practice in an organization or a company that is working well, something that is almost perfected or has quite some time spent on it. And you want to capture this best practice in a template, in software, in an application. And for DAOs, that could look in, or that could come in many shapes and forms. Imagine you want to keep track of a wallet address book of your partners and your contributors, or a project scope that keeps track of how a project should be executed on, or a legal contract. Because sadly enough, today's form templates are just a poor man's document model. They are not sufficient for what we are imagining and for the complexity that we want to scale open organizations or scalable networks towards. Now, why do DAOs also need document models? To stop contributors from always making the same mistakes, to save experience, intelligence, and skill sets from leaving a DAO, and to embed those clear guidelines that document models offer into software, and then also automatically measure critical data, as Teep just shown. Additionally, this structured data primitive that document models are running on also enables AI contribution in the near future. Now, let's make it a little bit more tangible. Here's a very basic document model example, maybe something you're all familiar with. You need to make a quote for somebody, and you don't want to start from scratch once again. And you might say, yes, in a centralized organization, this is just an Excel sheet, and there's a manager telling the contributor or the newly hired recruit how to make that price proposal. Well, in a decentralized organization, there is no manager. There should be a workflow in place to offer the partner that you're working with a price proposal quickly and easily. So in this template or in this document model, we can find items such as your preferred client, the base rate that you're invoicing at, and the specific package that you want to offer to this client. It also makes you not forget about the tags, any attachments, and provides you a subtotal. And that's exactly what document models also do. They are a smart template that help you to get through your process faster, smarter, easier, more effortless, and with the necessary guardrails in place so that you don't forget any of the crucial steps. Now, what is underlying to this document model is a data model schema. And that data model schema is, in our case, a GraphQL schema that collects all of the different object types that are necessary to develop an interface and to interact with the data of this document model later on. For example, in our rather low-key example of a price proposal, we can find in the object data type quote state, we can find other properties such as who's our client, what is the services that we're going to provide, what is the subtotal, and the tags that you will be applying. And it's those elements that make it very easy to then later on develop a document model from this foundational data model schema. So why exactly are we such a fan of these data model schemas? Because throughout the development process of such a document model, it becomes crucial that all of the different stakeholders, the developers, the builders, the analysts, and the designer agree on what they are about to produce and the solution that they want to put in place. And that step of being lost in translation is something that data models cover. Just like we are using English in this rather international crowd, we are using document models and their underlying data model schema to make sure that the different stakeholders are aligned and listen to each other's problems, structure it with the necessary types, and then represent it not only through this data model, but as a document model and the necessary context that comes along with it. So how does that happen? That happens through a rather traditional, it happens through a process, a design thinking process, and a business analysis process where you are diving into the stakeholder requirements, specifying a problem statement and a potential solution, which then distills all of the information into this data model schema. And as mentioned before, why do builders need such a data model schema? Well, we needed to solve that communication gap between PM, analyst, dev, and designer, but to also make sure that they are finally receiving the complete briefing and the necessary business requirements and domain context that comes along for the specific use case that they are trying to solve. Then let's just dive into an example and maybe a little bit more theoretic context around these data models and document models. I have 4 smaller examples lined up in the categories of finance, legal, governance, and people ops. And our first one is the one that Teep has just presented. It's the real world assets. So MakerDAO wants a clear and accurate report on their real world assets. And what can we see in our data object? We can see that the real world asset state requires the accounts to be specified, the fee types to be specified, and that asset is then collected in a portfolio. Exactly the steps that Teep has previously went through, and the necessary data is here collected. What we're also seeing is that we can then build that interface on top of it, and that interface is living inside of Connect, where a contributor can interact with it and add their content. Now, the architecture of such a document model is actually offering us the possibilities that Teep has just been showing. So we're making use of a set of chronologic operations that are being applied to a document model when you are modifying it. So those operations are processed by a processor, and we are turning them into a state of the document or in the next state of the document. So this set of operations is actually a history of what has happened to the document, and if in case you replay it, it would also result in the same final end state. Then what type of data are we collecting inside a document model? Not only the operations history, but also the content itself or the input data, what we here call the operational data. And then once we start making use of that operational data, putting it into read models and querying the read models for specific analytics, we get the analytics data that provides us with business insights. And it's those three types of data that actually turn a document model in self-contained database with API access that you can easily query, since the data model schema is a GraphQL schema that provides all of the necessary fields to query for the data, as Teep has shown. You can start automating it for different triggers or set up secondary actions that follow when certain data comes in. And that might be familiar to you because it looks a lot like how transactions are transferred or sent across a blockchain network. And that's exactly what is also happening with our document models. We're sending those operations across the different nodes. In our case, we call them reactor nodes, to synchronize a document across a network. And it's that append-only structure that then eventually also makes it very easy to use it for decentralized storage solutions or the specific storage solutions that an organization might favor. So as Teep has also mentioned before, those documents can live either in a local drive or in a team drive, depending on the preferences of the contributor or the organization. This visual highlights it once more. So when multiple contributors are trying to synchronize documents with one another, they will send those operations across the switchboard, which represents the server side of the infrastructure or the network layer here, after which the operations get synced and the documents get to their consensus state when multiple contributors are collaborating. And that happens through the interfaces such as Connect, where a private contributor can access to these document models, and they get stored in secondary nodes or remote nodes hosted on Switchboard. And additionally, we can also mention that it's possible to set up a reactor node that offers peer-to-peer access if you want to work together with a specific contributor and not necessarily in a remotely hosted network. Then some other agreements or other examples after I've explained this rather technical architecture of these document models. A legal multi-sig participation agreement. So these MPAs is something that Powerhouse is currently heavily working on. And these multi-sig participation agreements should, in the future, protect DAOs and open organizations from legal liability and form a reference of who is carrying what responsibilities and permissions within that multi-sig agreement. Now, here we see a traditional contract, which could very easily be translated to a data model schema, where we can find specific scalars that are very dedicated to our industry, such as, let me see where it is. I think there is an Ethereum address in here or an active signer address. So it's those custom scalars that we're developing with the team to cover all of the needs of our industry. That can then be turned into a document model where you could see an document overview of the current contract, maybe its effective start date, but also a management panel for configuring all the different participants in this multi-sig. And then secondarily, we can later on automate an update of the contracts when certain participants of the multi-sig step out or in of the agreement. A governance proposal might be close to your heart, or you might have been interacting with it. So what do we find in the data object of the governance proposal type. So we find the properties such as the title, who has been creating it, the different stakeholders, the status of it, the phases that the proposal will need to go through or that are being planned, and the evaluation metrics. Now that then once again is turned into an interface that a contributor or the broader DAO can interact with, which can then be posted on Connect to keep track of it, or later on a public transparency dashboard such as Fusion to keep track of the stages that a proposal is in, from being drafted to being funded. Then the last example is a billing cycle for people operations. So what we're seeing here is a contributor who would like to get billed or get reimbursed for the work that they are doing on one of the Powerhouse components, for example. Imagine they are building a document model and they would like to get paid for their work. So in this case, we see that the contributor bill state requires us to specify a stablecoin compensation line item or a proof of work token compensation line item. Proof of work tokens are a novel primitive that we're imagining, and that will represent the contributor's opportunity cost for contributing to these components, but also their reputation, and later on a potential to get a share of a retroactively distributed revenue share. So it's those line items that a contributor might want to specify on their invoice. And here we can see one of the custom scalars, such as amount token, that we're implementing in these document models, and that Liberuum will be showing you how to build and how to construct it from scratch, making use of the data model schema and adding an interface to it. So that brings us to a small developer demo. I'm not sure how many people will be following us along. It could be possible if you have like VS Code, Node, Git, Bun, PNPM installed. Let's see who is feeling like it.
Let's have a look at the demo. All right, I can take over. Hey everyone, good morning again, if you're sleeping. So I'll walk you through the Builder Flow demo and how quickly you can rapidly develop an application that involves, at its root level, a document model, and put that document model back in Connect and seeing the user interface in the end. So as a start, the requirements are very simple for a developer person. You need an editor like VS Code. You need Node.js, NPM, or any other alternative package manager too, like Bun, for example, and Git. And to start, there's a very simple command called create document model lib. And when you run this command, you'll first be invoked to name the project. So you, in this case, in this example, we'll call it contributor bill. And then this script, this command will generate the project for you, all the necessary dependencies, so that you can start developing. So we move into the projects folder, and as a next step, it will be for you to run a local version of Connect, so you can design the document model. The reason we allow you to run Connect is that not only developers can build here, but also any other members of the organization, like business analysts. So like T mentioned before, everybody in the team needs to reach an agreement to design the document model to a perfect level, so that the document model involves all the necessary rules that need to be followed. So in this case, we do run Connect locally, and you open it. So there you can basically add the document model schema that would define, for example, in our case, the contributor bill. So again, you can see that we are actually in our local environment here with the same tool, Connect, and we're going to click this button, document model, which will allow us to open the document model editor, and there we'll add the metadata about the document model, define the schema, prepare it, and then be able to export it that can later be used either locally or send it to someone else to help develop.
And so these document models, they're also just documents, which means that you can do anything with them as you can do with a normal document. So that means, for example, that you can also put it on a remote drive, or you can keep it local, or you can store it on chain. And for example, you can make it part of the governance process. So one application for Maker would be, as Maker wants to create a comprehensive Atlas book, which has all the governance rules and all the processes data defined. You could actually vote through a new document model, for example, through the governance process, and make that part of the DAO governance process. But in this case, we're at the other side of the spectrum. We're a single developer who just wants to create a new document model with editing.
So what's happening here is the first step, we're just adding this extra metadata about the document model, the description, the type. As we can see here, we define the new type of the document model, which in this case, it's sitting under the organization Powerhouse, and then the document model type, which is contributor bill, author, website, and the file extension. These are the first steps. After is we move down to the actual global editor for the document model. Here we are going to insert our new schema that will define the document model.
So in this case, as a contributor build, so we would expect things like line items, the issue date, and so.
Yeah, so very simple schema that will define this contributor bill. This contributor bill is defined by three types, three objects. And in the root type here, the contributor bill state, we see again these properties that defines a contributor bill. So properties like issued, issuer, due dates, line items for stablecoins, line items for reputation tokens, and recipient address. The underlying two types are just a inner structure that how a line item should be structured and organized. So in other words, once you get used to this language, which is pretty easy to get a grasp on, it's easy to start defining the structure of the document model in how you like it to be, and that in essence will define right away in written format the rules of a certain document model or your process in the organization. So the first step, you just define the structure of this document model. The next steps would be to define some input operations or functions that will help you modify the state of this document model. So you'll design as well the process of how the data will be added to this new data structure, to this new state.
And the other thing I want to point out here, if you, so this is what Teep was talking about. If you look at the different types of the data schema, then you notice, for example, that there's an inferior address, line tokens, and so on. And so these are primitives that are specific to the kind of organizations in the industry that we're in. And so what that means is that whatever the data structure is, the system knows that a specific field is an Ethereum address, and so it can be a bunch of functionality out of the box, and essentially, make specific features available for specific data types that we can define in the organization.
So I'll continue with the flow, and I'll share you, maybe my colleague will share the schema in the chat that you can just copy paste. So now you can just follow along and see the process, which is pretty simple. So the next step after we've added the root schema is adding these operations. And for that step, those operations usually live inside different modules because they be plenty of them. So first we define a module name, we call it contributor build, and then we add the operations. So of course, you'll need to have a root operation that updates, creates a new contributor build, and this is what we have now here. So on the left side, you see just the basic metadata about the operation. We define the operation name. And then on the right side, you see another editor for a input GraphQL type. And here inside this new operation, you add the required fields that will modify the state of the root document model. So in this case, when we update our contributor build, we need to update the issue date, the issuer, the due date, and the recipient. And then we'll add 2 more operations that will add stablecoin and POWT line items.
And so the important thing here is that we are essentially defining business logic that should be the same everywhere in the organization. So even though it's a decentralized organization, even though you have different people using these documents in different locations, maybe on a local computer or maybe on a chain or for example, a cloud server, it doesn't matter. We want the same logic to be applied every time. And that's why we define our operations here in the document model so that we then know that the same logic will be applied indeed everywhere where the document model is used.
So once we're ready, defining the state, adding the operations to the document model, checking out the metadata that everything is all right, then we can export the document model. And as we like to have decentralized data primitives, we make sure and it makes it as a feature for you to export, share the document model right very early in the development process. So it can be passed on to another team member or someone else for feedback and so on. So the next step will be to export this new document model. As you can see, it is being exported as a zip file. And then in this general format file, you can use it either importing it in another Connect instance and continue editing it, or using it now then to start using the code generators that will finalize the development of this document model.
So for example, if you're mapping all the processes, all the data in a large organization, this is the typical work that the business analyst would do. For example, define what an invoice looks like, define what a transaction looks like, define what a project looks like, define what a milestone looks like, and so on and so on. And so you can then make that either part of the governance process or just have it as features in a customized platform.
So you can see here that once we close the editor, we do see the document model as a document model type. And this is the editor that we just used to edit the document model. And you can also take this and pass it to someone else to continue editing it. But as we exported it, we then are going to use it for our local development to continue completing the rapid development. So we've opened our project in our IDE, our developer environment. And on the left, we see our just folder structure that is split into document model folder and editor folder. And then we'll use our newly created zip file to generate code so we complete the rest of the business logic.
So the 2 types of code that we're generating here are the business logic code and the editor code, which allows the user to enter a new place and change the values. If you were to use this in production, then you probably also want to generate the unit tests so that you can have the guarantee that all the logic is correctly.
So the next command for that will be to run run generate and the name of the zip file. We also, for easy purposes, we just put it in the root of your project here, that zip file that you just exported, and then you run the command. And this command will auto-generate a lot of code for you so that you just focus writing the business logic and nothing else. So once this script has run, a new subfolder has been created with the name of the document model, so contributor bill, and there inside we'll write the business logic so that it will help actually complete those operations. When you click a button and write an input into the form and press enter, this business logic will make sure that, the data that you wanted to be added to the state is actually added. So here you see that we have 3 operations: update contributor operation, add stablecoin line item operation, and add PowT line item operation. They are representing the business logic of these operations in the sense of modifying the state of your document model. So this is a very general pattern used by developers specifically. So for them, this is like writing hello world, and it's a very straightforward process. So this completes writing the business logic for the document model for, let's say, for the backend. Then if you like to pass this now document model to someone trying to integrate it into an API, they can easily take it and integrate it because the important structure is already there. Now we're going to add more code, but for just developing a user interface and to start to represent how the document model will look like for the end user that can be used in Connect, for example. So another command, and here we write run generate, the editor name, and then we define the document type that we have created, which in this case is Powerhouse contributor bill document type. And this script, again, reads the document model zip and generates all the necessary boilerplate code so that you only focus on writing your UI components. This is React, so writing a quick user interface, it's quite fast. So in this example, we just copy paste the code and small React code that will basically showcase in the end the UI component. So after pasting the code, you save the file, and again you go back to the terminal and write run connect, and you spin up again the local version of Connect, and there you'll find a new button that will be called contributor bill that will allow you to open a new contributor bill document model. So as we can see here in the top bottom right corner, we have a new document that we can open, which is a contributor bill document. And when we create it, we're welcomed with this new UI code component that backs basically the user interface that we're seeing here. So if you look closely from top left, we see again the fields that we have defined in our schema. At the beginning, we have an issue date, a due date, then some input field for the issuer, an input field for the recipient, and 2 tables for adding more line items, either for stablecoins or PowT reputation tokens. So this represents basically the structure of the document model. And in the end, it's we give you the power to focus fully on the user experience and making sure to create the right looks, the right components that will back your vision of a certain process within the organization. In this case, a contributor bill. So
And so because you're building on the document model framework, you can, for example, just say your to the bill and email it to someone, and they will be able to open it and connect and see it. So if you don't want to email software in pain, you can choose to either put it on cloud drives or put it on decentralized storage. This is very flexible because of the underlying model that it uses, that is based on the transaction history of the document.
So what's happening here, we're just now adding some line items to each table. And then at the bottom of it, we see a summary of it in this table here, but also we decided to show you the raw data structure of the final output of this document model, which in the end is in a JSON format. And here you can see that, yes, once we have added the data through the inputs, we see that the fields are being filled now. So we see an issue date, an issuer, the due dates, a list of these table compensation line items or penalty line items, and so on. In the end, this is the raw data that is being modified by your designed document model schema.
And so these data can then be used for integration and automation. It's structured in a way that's very well suited to implement AI contributions as well. And so what we're doing with the builder team is to make it so fast to create these document models, these editors, that you can essentially capture all the information in the organization, scalable knowledge organization, in data structures like this, and make it fully digital and well.
So that completes our demo. You can see that it took me 6 minutes to film it. So once you get the gist of it, it's pretty fast to spin up a new document model from idea to a final user interface, final product. And that's what we're trying to achieve here. We try to give you the right tools to have rapid development within the organization for your specific business processes. And of course, once we push this is running locally. Yeah, you can develop your document model locally, but then you can easily connect to a colleague peer-to-peer or to a remote drive and have this work synchronized within the organization. And all the data that is then synchronized within the organization can be used through an API, through a GraphQL interface, which you can call and see, for example, an output of your recently added information through the document model.
Yes, and I'll try to keep it short, but just to tie it back to the bigger picture, I think is probably useful. So I'm not going to explain all of this, but this is the general architecture of what we're building out. You see at the bottom that we have, for example, our reactor nodes with the different storage adapters that can save data wherever you want it, local, cloud, or a decentralized storage medium. And next to that, we have our scaling infrastructure that Teep was explaining, which allows you to take that data and scale it up horizontally, essentially infinitely, as long as you have resources available. The whole system is based on a plugin architecture. So the four hosting applications that we have are Connect, Switchboard, and then Fusion. And so our document models that we were talking about, they can live in these different host applications as plugins. So as a developer, for example, if you want to create a new module, what you would do is you would create a package with, for example, a bunch of related document models. So you could imagine like a project management package that has maybe like milestones, maybe a Gantt document, you name it. And then you can bundle that together and make that available, not just the input side of things, but also the operational data model and the analytics data through either Connect or Switchboard, or you could use Switchboard as a backend to show that same information on the platform, the collaboration platform. And then lastly, there is also Renown, which helps, so it allows users to log in, authenticate, sign their transactions, and so on, and tie it to their Web3 identity. And so the way that we will be packaging this is indicated here in the blue boxes. So we'll be creating, as I mentioned, like for example, we'll actually be looking at the different roles in the organization, and then create on the Connect side a tailored experience for that specific role in the organization. So for example, if you are a Maker Sky contributor, then there are certain tasks and data that you need to have available in order to fulfill your role in that organization. And that will be as an app that you install to Connect, and your data will then be aggregated with all the other contributors' data through the Switchboard layer. And you can create multiple of these apps based on the different roles in your organization. So one other role that we mentioned are the real asset arrangers at Maker, for example. Today we looked at just a separate document, which is the report, but you could imagine a more complete experience that you install as a plugin to Connect, and that you can then use to fulfill that role. What you then get is a experience that actually looks more like an operating system. And so this is the direction we're going. All these document models, they will not just be like loose documents in a flexible, free to define folder structure necessarily. We want to give a lot more structure to it, because if you imagine like the Uber or Airbnb experience be just a bunch of folders where the Uber drivers or the Airbnb hosts have to figure out where the documents are and like which documents to create and when to create them, that would be pretty awful experience. And so these apps essentially allow you to create a UI layer overview, or overlay rather, of a Connect drive, and create a tailored user experience for the roles, the different roles in your organization. So the two platforms that Powerhouse is developing for itself and for Maker are the decentralized operations platform, which we need to operate as a scalable network organization ourselves, and the builder platform that we talked about today, which is required to essentially bring down the cost of adding new modules and features and so on, so that we can build truly big feature areas and customize for very cost efficiently. And once you build that infrastructure, then there is actually no reason to stop at, for example, decentralized operations, because you could take a lot of that functionality and to try to break out of the crypto bubble, for example, breaking into the traditional operations industry or like ERP software, which we think is an opportunity to be the first application that truly breaks out of the crypto bubble and escapes the gravity of the finance and speculation applications. As we then continue with the last slide, so we don't want to talk much longer about scalable network organizations tonight, but I do want to give some idea of what the scalable network organization model looks like and how this kind of maps onto all the things that we've been discussing today. So our idea of a scalable network organization, and so this is the question of how can DAOs ultimately scale up, is that scalability goes in both directions. So you need to be able to start small, start lean and cheap, and then as you scale up, add more complexity and unlock more organizational capabilities as you grow. And so this is what is reflected in this model here. So as an individual contributor, maybe you are only using one wallet, And then as you are building a team, maybe you're building a certain feature or you're offering a certain service, then you start using a multisig. That is still very informal, and maybe you can do that when you already received the grant or something, but after a while you will probably want to make that a little bit more formal and a little bit better defined on the legal front. So that's when our legal primitives kick in. The level 3 is a multisig that has 2 legal elements added to it. So one is the example that was already used, which is a multisig participation agreement, which essentially controls the liability risk of the different signers in the multisig. Because many DAO contributors may not be aware of this, but if you are a signer on a multisig, you're moving a lot of money around. If something happens, then maybe there could be some conflict and some legal consequences that arise from your role as a signer on a multisig. To improve this even further, we have researched and are now implementing for Powerhouse a legal wrapper around the multisig, which offers additional liability protection against outside risk as well, not just internally within the team. Then as the organization grows even further, we start to identify, I'll need a little water first. All right, so as the organization then grows further, we can start distinguishing multiple functions in the organization. So we still have a single legal entity, but we start to separate between functions such as IP management, actual revenue generating activities, the relationship with investors, and of course also relationship with the contributors, so the operation side of the organization. Now, within the original legal wrapper, there are already a number of legal primitives that can be applied, things like additional contracts, agreements, the proof of work tokens I looked at. They are also already useful within that context. But at one point, as your requirements grow, you might want to start breaking out these functions one by one and create dedicated legal entities to become part of the DAO. And so this is what you see here. The operational hub, the IP, SPV, revenue generating hub, and OCF are essentially dedicated legal entities to deal with these different functions in the organization. And then if you truly start thinking on the level of an Airbnb or another SaaS platform like that, you won't have enough with just one legal entity for each of these functions. You will need to start splitting them up even further. So, for example, the operational hub that you might use to contract contributors, you might want to start specializing per jurisdiction, and maybe have specific expert hubs, or different types of employment. And so this is the model that we're following and further developing as the Powerhouse organization itself grows. We are ourselves on this path, and we are of course working with Maker, which is already a bit further ahead. This is the organizational model that we're looking at to develop our technical primitives, our document models, our applications for Connect, our platforms, and our features. And they are all built to facilitate the growth of organizations like this. So from a single wallet to the like big scale SaaS platform with many users. And I think that will be it. So thanks all for your attention, and I'm happy to hear if there are any other questions or comments.